So, hi everyone, I'm Manon, and what I'm presenting today are new features that got implemented into ipyaladin in the last year. And this was a common work with Mathieu and Thomas, who are the main developer of Aladdin Lite, and Tom, who was on our intern this summer. So let's jump right in. First, what's ipyaladin? It's a Jupyter or notebook extension that is based on Aladdin Lite. So Aladdin Lite, we heard about that a lot, especially because it's used in adass-ipyaladin and other science portals. And how did we put that into a notebook? We used the AnyWidget framework, which allows us to be compatible with a lot of notebook viewers. The most known ones are the Jupyter ecosystem, including JupyterLab, Notebook, JupyterLite, also Jupyter Desktop. And if you're not into that, it also works in VS Code, in Google Colab, in Marimo, in Voila, Voici, and Panel, and maybe others. And this is because the AnyWidget framework defines a standard of communication between widgets and Python. So anyone building a notebook platform can support AnyWidgets. So that's where you can run it. But now, how do you install that? It's as easy as doing a pip install ipyaladin and nothing else. Don't do JupyterLab extension stuff or anything, and then it should work. Then we import that into our notebook, and here I'm using JupyterLab, and you import the package here, and then you display an instance of the object that you just imported. Voila, a fully functional Aladdin Lite appears in between the cells. But this is not how I like to use ipyaladin. Usually I like to put that on the side, and in JupyterLab you can do it with JupyterLab Sidecar. But if you're using one of the other notebook displayer, then there is a way of doing that. So how do I do it? I also import JupyterLab Sidecar here, and I display an Aladdin instance inside of a sidecar. When we execute that cell, it looks like this. A window pops on the side, and this is Aladdin Lite that will interact with Python. So the first thing that I'm going to do here is that I'm going to say that a new target for the window will be M1. So I'm sending this string from Python to JavaScript because widgets are written in JavaScript. So voila, I'm doing it, and it changes the center of the view. And here I've done something simple. This is a string. Strings also exist in JavaScript, so I exchange something that is easy to transfer in between the two. And now I'm giving you the theme of the talk, which is a lot of the new features that were asked by people were, how do I use AstroPy stuff into ipyaladin? Because this is a Python widget, and I want to use things that I'm familiar with. I don't want to transfer everything into strings or VO standards. And so this is why we implemented a lot of stuff, like supporting sky coord and angles from AstroPy. So here, let's do the same thing, but this time with a sky coord. So I'm importing the sky coord. I'm creating one from a name. And then this time, I'm not assigning a string. I'm assigning a sky coord object there. Let's execute that. So we do that, and here we move. So now it works. We have something that has a bit less friction. So I can now do the same thing for the field of view by using an angle object. And let's do that. And here, voila, I just used a 15 arc-minute angle and set that here. So the two examples I've shown you are communication from one side to the other. We have something into Python, and we put that into the widget. But now let's do it the other way. I have something in the widget, and I want to get the information back into Python so that I can use it in my analysis. Here, let's do something very simple. Let's say I want to estimate the size of this galaxy's cluster by using the zooming and panning of ipyaladin. So let's do that. I'm unzooming a bit. This is too much. Zooming a bit. Now I'm happy. And what I'm going to do here is reading the field of view property of the Aladdin object and assigning that into a variable. So when you move in there, it actually actualizes a lot of things in this object here that are always in sync with the Python. This includes the WCS of the current view. This includes the field of view, the current target, those kind of things. So now when I'm executing that, I see that I recover an AstroPy angle and you recognize the beautiful output of them. Let's go into a bit more complicated objects. Now that I have a center and a field of view for the object, I can draw a circle that estimates where the cluster is. So let's do that. This time I'm using not a core AstroPy object, I'm using an AstroPy region, which is an affiliated package, but that was asked by a lot of users, so we did it. So now I'm creating a circle sky region from the coordinate of the center that we got before and the dimension that we just got from the widget. And the other parameters are cosmetic ones. We do that, we get the circle, and if I open the stack menu of Aladdin Light here, it looks like that. The Python region appears with the name that we gave here into the overlays. The classification in Aladdin Light is everything that has pixels will be in surveys, everything over the pixels will be above in overlays. Okay, so this was a very simple region, but we also support ellipses, lines, polygons, and rectangles. But if you need someone else, you're very much welcome to ask for the feature or to contribute in the GitHub repository. That is actually the link that you have here on the top of the slide. Let's go on, and now let's say that I want to read a fits file. This is one of the new features of Aladdin Light v3, so let's do that. I will add a Chandra observatory image because there is one next to this Perseus cluster, so really cool. Here I'm using a fits file that is in the file system, so I'm giving a path to it, and I'm just giving a name so that I know what it is in my stack. Let's execute that. We see the pixels appearing here. And if I zoom in, we see the beautiful structure around the center of the cluster. This was using a path, so not an AstroPy object, but it also supports, if you put in entry here in add fits, it also supports images and comp images HTU. Let's go further. Now that, I will still keep the image for a second. Let's say that now my task is to annotate this image by keeping the area that is in the shockwave that we see here that we guess. To do that, I can work with multi-order coverages, the space ones, and I can draw the mocks, which is one of the super new features of Aladdin Light that I love, by going into the stack, saying I want to put a new mock, and then I say that it's from a selection, and I will draw a polygon. Let's do that in a few steps. This is my polygon, and when I finish, I have a mock that I can use later in my analysis. So that's one way of annotating a lot of images directly into the widget, and then we can use that back into Python. This was getting a mock from the widget into Python, but we can go the other way. We can have a mock in Python and put that in the widget. To do that, I'm using MockPy, the library that is an affiliated AstroPy package, and that allows to manipulate mocks. Here I'm getting the mock, so the coverage, where is my pointer? The coverage of a Visio catalog that has galactic candidates, extra galactic candidates, and I'm putting this coverage into the view with the add mock method of the object. So here it is. We have a coverage that just appeared into the widget, and we can do that to any space coverages that you could have. When I say any, here we use a MockPy object, but it also accepts the standard other ways of providing a mock. If we say that now we have only seeing one IPS, let's change that. We can do it with the interface, like in Aladdin Light. And one of the new features of the v3 is that you can filter with only IPSes that are in the view, or filter with only IPSes that are in a specific wavebands that you're interested in. But now I'm showing you how to do that with AstroQuery mock server that allows to access everything that are in IPS nodes and find them by position or by keywords. Here, let's do that by keyword. I'm importing the AstroQuery submodule, and I'm saying that I want to find Euclid-related stuff. And if I only print the identifiers of those IPSes, I get a short list. And let's say that we want to see the visible channel, the optical channel being visible. I assign to the survey the identifier that I got from the mock server, and this was already executed here. We get the pixels back. If I zoom in a bit, we get these beautiful heaps with a high resolution. And let's say that my job now is to get cutouts of that so that I can analyze those galaxies in more details. So to do that, I will want to extract the fits of the current view. And I can do that with the method getViewAsFits. And this gives me a fits image into this variable. We can print that. And here we are. We recognize, for example, this bright spot, which is this one, and this one, which is this one. And behind the scenes, thank you, it calls the hips to fits cutout service. So you really are not accessing the pixels that Aladdin Light are showing you, the approximated ones that you don't want to use for your analysis. You're accessing the ones from the server that can be useful for science. Yeah, this is me saying this is hips to fits, and it's also available in AstroQuery. I will go very fast because I was a bit too slow in there. You can print catalogs, and here I'm saying that I have 2 catalogs from the extragalactic database that I'm getting from the AstroQuery Vision module. And the feature that I really want to show you, that is the last one of the talk, is how to get sub-selections of those catalogs from the interface. To do that, I will say, for example, I'm interested in the middle. I do a right click. I have the Aladdin Light menu, and I say that I want to select sources and say I want a circular selection. So then I do my selection interactively, and this updates one of those things that are always updated on the Python side. It goes into selected objects. Here we have added 2 tables, so the length of that object will be, I'm showing that we have them, will be 2. And let's look at the second one. This will be the second catalog, but only the part that is selected from the interface, and that's the new feature. As a conclusion, I really want to stress that we are compatible with a few AstroPy affiliated modules. You really, if you need someone else, don't hesitate to come and talk into the issues. And we love interactions with the people. The thing I want to stress is that we got a bit of the best of 2 worlds there. We can do an analysis in Python and do like everything you can do with the common and popular modules, but we also have a visual help on the side that shows you what you're doing on a very quick widget that is easy to install. And that will be my conclusion. You can contact the CDS or me if you have questions, and thank you a lot for listening.
Okay, this concludes the first session this morning.